Hey guys, welcome back to the channel. Let's see what we can do today. So I'm going to be revising some old topics that I did last time in the past few streams, because I want to see if I can solve it again and in a better way, or if I can solve it faster. So here we go. Today we're solving longest increasing subsequence. Let's see what the problem statement is. Given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is a sequence that can be derived from a given sequence by deleting some or no elements without changing the relative order of the remaining characters. Okay, let's see what we can do. I already know this is a DP question. But let's see, let's just try to get the intuition behind it. So we have nums here 9, 1, 4, 2, 3, 3, 7. Now we want to, okay, longest increasing subsequence. To find longest, we like intuitively, if you think about it, if you want to find the longest increasing subsequence, that means you need to know all the subsequences, increasing subsequences, and from there you can pick the longest one. So yeah, that's what I'm thinking. Um, how so and then the question can be solved by me finding a way how to get the length of an increasing subsequence through in this array. So I think about it that way. So let's just take an example. So 9, this is the smallest increasing subsequence. Then 1, 4, 2 is 1. Then 1, 2, 3 is 1. Then 1, 4, 2, 7 also comes. 1, 2, 3, 7 is 1. Then what else? 4, 7 is 1. 2, 3, 7 is 1. 3, 7 is 1. 7 is 1. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 7 subsequences, and from this we can see that 1, 4, 2, 7 and 1, 2, 3, 7 is the longest increasing subsequence. Okay, uh, so this for some reason this makes me think about. It reminds me of the problem where we are trying to find uh, the power set of a set, and the only way to find the power set of a set is to like go through all the iterations. But in this case, there is a condition that's involved. So basically, you could think about it, think about solving it like in the similar way that you would solve the subset question, which was again recursion and DP. Um, so what to do? Okay. Um, so what can I do? I remember that I solved the subset question by using the pick don't pick method. So that is the that's something we can use. Try to let's try to write the recursive relationship. Um, 1 second. I was doing all of this on my notebook. It doesn't look great on the during the video. 2, 3, 1, 2, 3. Okay, let's see what we can. Okay, so what to do? What to do? Okay. Um. So I want to. how do I how do I find, okay, let's see, how do I find a subset with the condition that is given to me, which is the elements should be in increasing order. So to get the subsets, start with an empty set, and if I choose to pick, so I have many options from here. If you think about it, I can put 9, I can put 1, I can put 4, I can put 2, 2, can put 3, blah blah blah. I can keep on going. So just to keep it short, go here. Now from this, I can from 9, from this point. So now I was equal to 0. Was it equal to 0? No, no, no. Okay, now that doesn't make sense. Okay, forget that. So 9, from 9 subset, I can add element to this subset if the element is greater than this element. So 1 is not greater, so I will not add. Then the other option is not picking the next element. Um, but this that is same as this. So I don't really need to do this again, do I? I don't think so. Then from one I have an option to pick the next element and not pick the next element. So if I pick the next element, it's going to be 1 comma 4. If I don't, it is going to be 1, right? Yeah, this looks better. So if you see, you can see that I am kind of forming a, let's just put it here because that's the method that we are aligning ourselves with. So yeah, what can we do next? Okay, so I would, mm, yeah, that's what I'm thinking. I should come up with a recursive relationship and then only go to coding. So we'll try that. So longest increasing subsequence. So I need to, I can only return the length once I have reached the end. So once there are no more elements to check. Oh my god, what's wrong with method? So yeah, so let's say f of, okay, I have an idea. So if you want to get a recursive relationship, so f of the longest increasing subsequence would be f of, let's say, I comma nums. It would be, from here you can say that it's um, either I include I, so it will be like 1 plus whatever I plus 1 gives me, uh, I plus 1 nums. So the array from I plus 1 till end, this, whatever is the longest subsequence for this array plus 1, if 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 the I plus 1 element is greater than this element. Now I have another doubt actually. Okay, will this always work? What if let's say, well, what if this is there 0 3, and then I think it is fine. Can't think of a scenario where it might break. because we are always comparing with the adjacent adjacent element, or the element that the array starts from. So in that case, should be fine according to me. Okay, so whatever this function returns me plus 1, given that the I plus 1 is greater than I, if it's not, then we don't call it. Then we don't call this function. And what else? And then I also have to explore this option where I'm not taking the current element and I'm doing I plus 1 nums. Like in this scenario, if I don't take this element and I try to find the longest increasing subsequence in this subarray, I will end up getting a good number. I'll end up getting the number. But if I take this, I'll always be stuck at 1. So yeah, this is what I'm thinking. So you can say it's equal to max of these two, right? Comma. Yeah. Um, yes. Yes. So, okay, I got distracted for a second. Here we go. I am going in with my helper function. Enough theorizing. Let's do this. Self, comma, current positions. I'll just denote it by p nums list int. Okay, so if I'm at the end of the, if okay, if p equals, if p equals what is this, nums I, no, sorry, length of nums, then we return 0, 0, as we can do a pick don't pick kind of situation with a condition. So for pick, I don't know how it goes, bro. Okay, so for pick, I would do, what would I do? Really, what should I do if it's pick? Um, I should I should first check if nums nums p is less than nums p plus 1. Okay, now this will be a problem when we are at the end. We could do something like, if we are at the last element, we are, we are at the last element, I should control Z. Okay, I'll handle that edge case scenario later. I will just do this first. So if this is the scenario, then I want to call self self dot helper call p plus one comma nums. That's it. I want to call it, and I want to return. Okay, not return. Just I will just define a variable called uh, uh, pick equals zero. Don't pick equals zero. We'll define it as pick equals one plus. Okay, now what do I do? What should I do? Should I do? Uh, else pick is zero. If this condition is not, then there is another condition which is don't pick equals whatever this guy calls. Okay, if it is zero, it is zero. Oh God, feeling feeling distracted already. Might end this stream soon, but whatever. Self helper p plus one. Don't pick now. What should I do? Return max of pick, comma don't pick. Okay. This is cool, right? So this is fine. This is fine. Okay, the edge condition where p plus one is equal to this, or when we are at the last element, what are we trying to do? If it is getting called, if it is getting called, that means, okay, let me see, think about this. How mod it is equal to minus 1, I return 1. If it has reached that position, then I should return 1, right? That makes sense, because I would have called it only if this condition would have satisfied, or it would have been a don't pick condition. I think it should work that way. Return, return nums p is 0. Let's see what it does. Oh wow, passed. Submit, it will give me TLE or something. Wrong answer. What? No fucking way. I'm getting wrong answer. Yeah, I'm surprised as hell right now. Huh. Okay, weird. Must be missing something. 4. My output is 4. Something I'm missing. Okay, anyway, I'm gonna have to end the live here because I'm not feeling well. We'll circle back to this again. Maybe I'll do a stream where I'm solving it using DP. Um, I will debug this problem offline because, yeah, we're out of time. Okay, thanks for joining. Bye 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 bye.